Hello, in this video we're going to be working through exercise 1, which you should have tried to work through on your own. So the solution is provided as a way for you to check your answer. We're going to be repeating the directions for example 1 from this section with the sequence -3, 6, -12, and 24. So just to recall, example 1 said to find a formula for the general term a sub n of the sequence. So we need to find a sub n. And then it also said, using this formula, calculate what the 8th term of the sequence is. So we need to find a sub 8. That is assuming, of course, that we start with a sub 1. So let's do the same process that we did in the previous solution, which means we're going to write out our terms. A sub 1 is -3, a sub 2 is 6, a sub 3 is -12, a sub 4 is 24, and we are going to assume that this pattern continues from here. So -3, if you recall from the previous example, from example 1, we ended up writing things as products and sums. So let's see what we can do here. We could potentially write this as maybe 6 is equal to -3 plus 9, but then if we added 9 to 6, we're not going to get to -12, so it's not quite as simple as that. What if instead we wrote it as a product? So if we were to multiply -3 by something to get to 6, well, that would be a -2. Now, if we took this number and multiplied it by -2, we would get to -12. We take -12 multiplied by -2, we do get to 24. So that pattern does work. So we can write a sub 2 as -2 times -3. And then our next one, -12, we can write that as a -2 times 6, or a -2 times -2 times -3. But notice that's the same thing as -2 squared times -3. Now this last one, 24, is -2 times 12, -12. And we know that -12 can be rewritten as -2 squared times -3. So -2 times -2 squared times -3, or we could write that as a -2 cubed times -3. Now, if we start comparing our patterns, we have -2 cubed times -3, -2 squared times -3. So the only thing that is different between those two is just our power. The -2 stays the same, the -3 stays the same. If we compare that to the previous one, notice that we could write this as -2 to the first. So again, it's just our power that changes. And if we continued that pattern to our first term, we could write this as a -2 to the 0 times -3. So one way that we could write our explicit formula is -2 to some power, we'll come back to that, times -3. This is the nth term. We always have one less than our power here because we chose to start at 1. So that means we need to have a -2 raised to the -1 power. And oops, I don't need that. We do need to write that this is for n equaling 1, 2, 3, and so on. A couple of notes if you did this differently. First off, if you started with n equals 0, so in other words, you said a sub 0 was -3, a sub 1 was 2, and so on and so forth, well, then this would lead to a formula of -2 to the n times -3 for n equaling 0, 1, 2, and so on. Okay, so you might have done that differently. Another option, if you factored the numbers more. So what I mean by that is, let's say we had a sub 1 being -3, and you rewrote this as a -1 times 3. Then a sub 2 was 6, which was -3 times -2. So -3 we can rewrite as -1 times 3, and -2 we can rewrite as a -1 times 2. So this would be like a -1 squared times 3 times 2. A sub 3 would be, let's see, what was? A sub 3 was -12. That could be written as, oops, I am so sorry. -12 could be written as -2 times 6. -2 could be written as, or factors as -1 times 2, and 6 could be written as -1 squared times 3 times 2. So now we have 2 2's and we have 3 negatives. So you could have -1 cubed, 2 squared times 3. A sub 4, if you continued this, you would end up getting it written as -1 to the 4th, 2 cubed times 3. So then the pattern in this case is that a sub n would be, let's see, we have, for a sub 1, we have -1 to the 1st power. A sub 4, we have -1 to the 4th, so that means -1 to the n. We have 1 less than that for the power of 2, so we would have 2 to the n minus 1, and then we would multiply that by simply a 3. Okay, so that's another option. So notice with these explicit formulas, there are multiple options for correct answers. There isn't necessarily only one answer. As long as you come up with a pattern that works for all of the numbers that are given to you, you can assume that the rest of the numbers follow that pattern as well. But you do need to make sure that you come up with some sort of pattern for all of your numbers. You also need to make sure that you include your starting values or whatever your starting index is, okay? Because the number will not necessarily make sense without that. Or, as it was shown up here, you may have a slightly different formula if you start with a slightly different starting index number, okay? We also need to, with any of these formulas, figure out what the 8th term is, because that has been asked of us with this problem. So I'm going to go back to my original formula. A sub n was -2 to the n minus 1 times -3. So with n equaling 8, since we started at n equals 1, the 8th term is n equaling 8. Then a sub 8 is going to be -2 to the 7th times -3, which if we plug that into a calculator, we will get 384. Or of course you can raise -2 to the 7th in your head, multiply by -3 if you would like. But for the sake of getting a perfect score on homework and or learning activities and a test, feel free to use a calculator. So 384. One last thing that I want to note: if you started with a beginning index other than 1, so for example, with this formula, when we started at n equals 0, our first term corresponded to n equals 0, which would mean that your 8th term then would correspond to n equals 7. So you do need to be careful with picking the correct index value to correspond to the correct term. So that's one of the reasons why having your beginning index written out is extremely important.